Something extraordinary is happening in a quiet hangar far from the global spotlight. Engineers gather around an aircraft that, according to its inventor, powers itself without traditional fuel. Today is the day the world finds out if this unbelievable claim is real or another dream crushed by doubt. As the sun cuts across the runway, the tension is impossible to ignore. If this plane lifts off the ground under its own power system, it won't just rewrite the rules of aviation, it will challenge everything we know about energy, innovation, and the limits of human imagination. The story begins with a man who refused to accept that innovation only happens in giant labs with billion-dollar budgets. The inventor, working from a small workshop, spent years experimenting with unconventional energy principles. Most people dismissed him as unrealistic, some even called him delusional, but he had one advantage they didn't: persistence. He observed patterns in electromagnetic waves, static fields, and resonance, convinced that nature itself hides untapped forms of usable power. When he first shared his theory of a self-sustaining propulsion cycle, experts laughed. Traditional physics claimed it was impossible. But the inventor wasn't chasing approval, he was chasing proof. Piece by piece, he built a system that could generate continuous power from environmental frequencies. Then came the boldest move, scaling that system to fit into an aircraft. And now, after years of rejection and self-funded research, the world is finally watching. As news of the self-powered plane spread online, critics wasted no time. Aviation forums mocked the project. Engineers accused the inventor of posting clickbait science. A few labeled it a scam designed to attract attention. Mainstream experts insisted that no aircraft could fly without fuel, combustion, or stored electric battery capacity. They demanded data, schematics, equations, none of which the inventor released publicly. Some said he was hiding details because the technology wasn't real. Others believed he was protecting his work from being stolen. The pressure grew. Interviews turned aggressive. Headlines cast doubt. Yet despite the criticism, one fact remained impossible to ignore. The plane existed physically, and today it would be tested for everyone to see. That's the moment critics fear most, the moment when doubt meets demonstration. In the hangar, the inventor didn't respond to the noise. He worked quietly, tightening bolts, checking circuits, reviewing internal diagnostics. He knew something the world didn't. If the system performed exactly as designed, the takeoff would answer every question without a single word. The aircraft doesn't run on aviation fuel, it doesn't carry heavy battery packs. It doesn't rely on solar panels spread across the wings. Instead, its heart is a compact power unit that channels energy from environmental sources, specifically radio frequency fields and ambient electromagnetic waves. The system collects, amplifies, and converts these frequencies into clean electrical power. Traditional engineers argue this violates established energy laws. However, the inventor insists the system isn't creating energy, it's harvesting what already exists in the environment but goes unused. Imagine the air around you filled with invisible rivers of energy. This plane is designed to tap into those rivers the way a windmill taps into wind. But the breakthrough isn't just the harvesting, it's the stabilization. Aviation requires consistent, uninterrupted power. Any fluctuation could be catastrophic. The inventor spent years building a frequency stabilizer, a device that smooths incoming energy and converts it into a steady power stream for the motor. If this stabilizer works at scale, it could unlock a new era where planes, cars, and even homes run endlessly on distributed ambient energy. But if it fails today, the dream ends. The runway is unusually crowded. Journalists set up cameras. Engineers monitor laptops displaying real-time telemetry. Support staff pace nervously. The inventor climbs into the cockpit with quiet determination. Before takeoff, he performs the steps critics have doubted for months. No fuel truck approaches. No battery charging station connects. No external support system is attached. He simply activates the onboard unit. A faint hum fills the air as the frequency converter powers on. Panels light up, instruments stabilize. The crowd falls silent. A local official overseeing the demonstration steps forward to verify the fuel tank is indeed empty. The battery compartment contains nothing more than diagnostic systems. This moment is historic or humiliating. The inventor gives a thumbs up. Dozens of phones rise to record. He pushes the throttle. The propeller begins spinning, not sluggishly, not hesitantly, but with smooth, steady acceleration. Gasps ripple through the audience. For many watching, this is the moment where disbelief becomes anxiety. If the plane moves, everything changes. If it doesn't, the world will laugh louder than ever. The nose of the aircraft dips slightly, the wheels roll forward, and the runway test begins. Section 6, the takeoff 220 words. Total so far, 1,096 words. The plane gains speed faster than expected. The hum of the engine grows into a confident roar, clean, even, unwavering. By the time it reaches the midpoint of the runway, the crowd realizes something shocking. The speed is not dropping, not fluctuating, not struggling. The onboard system is holding steady. The inventor gently pulls back on the control column. For a brief second, the plane hovers between doubt and belief. Then it happens. The wheels lift off the ground. The aircraft rises smoothly into the air, defying every critic, every article, every expert who said this day would never come. People on the runway shout, cheer, and cry out in disbelief. Even the skeptics recording on their phones lower their cameras in stunned silence. The plane circles above the airfield, powered continuously by the invisible energy field surrounding us every day. The flight lasts several minutes, not seconds, not a brief hop. Each second in the air is a direct challenge to conventional science, a living contradiction to everything taught in engineering textbooks. Finally, the plane descends and lands with the same calm power it took off with. When the wheels touch down, history has already been rewritten. Within hours, the video of the flight spreads across the internet. Some call it the greatest energy breakthrough of the century. Others insist there must be hidden batteries or tricks behind the scenes. Aviation analysts warn that if the technology is real, it could destabilize entire industries dependent on fuel and maintenance. Environmental groups celebrate it as a solution to carbon emissions. Big corporations watch nervously from the shadows. What happens next could shape politics, economics, and technology for decades. Will investors line up to support the inventor? Will governments ignore him or pressure him? Will energy giants attempt to buy, bury, or control the technology? No matter what the future holds, one truth is undeniable. The world will never again dismiss innovation simply because it didn't come from Europe, America, or a billion-dollar lab. The test flight proves that Africa is not just participating in the future, it's shaping it. And somewhere, in a modest workshop, the inventor begins planning the next version of the plane. Whether you believe the science or not, the flight you witnessed forces a question we can't avoid. What if the limits we think exist aren't real at all? What if the next breakthrough doesn't come from the world's biggest institutions, but from overlooked innovators daring to think differently? If one man can challenge global aviation with a self-powered aircraft, imagine what thousands of determined thinkers across Africa could achieve. This story isn't just about a plane, it's about possibility. And possibility is the one force no one can stop.